to the last part of database. So we'll continue with object relational mappings, but I'll show you first the codes, the minimize codes to implement SQLite. So here, we export the library to be able to use by server.js. And remember, we created a contacts.db using SQLite 3. And then here are HTML. As you can see in the body, we implemented the script. So imagine the body as like the physical location of the library that allows us to implement this in this function. So the head is a structural style. These meta tags define encoding viewport settings and title of our library. So the head define the title. Here the head define the title that will show in this library on this on the search bar. And then buttons and tables. So the button loads a list of registered visitors like this. So if we add, let's say, J and then E. So this button add contacts. Okay, so it's a dynamic. It retrieves load books. The button ID load books retrieve all the books. So here the button that's the button ID, and then the button ID add book, adding a new book to the collection. A librarian manually enters a new book in here. So that's the button for that. Load loans, check in who borrowed what, and then add loan, issue loan, or add a new book borrowing record. So JavaScript could be thought of as a librarian's brain. The document that event listener DOM content load. Librarian awakens and start managing the library, waits for the library to be fully built before taking action. So the document that add event listener here is like a librarian waking up and then it waits for the library to be fully built before taking actions. So it creates the structure for the library first using those things as well as the back end for the books to prepare. If someone asks for a book, loans, or contacts, the librarian fetches them. So it's an asynchronous function. Let's say someone wants to load a button, load all books, or load contacts. The librarian calls the archives, queries the database to retrieve the records. So that's the load contacts, load books, and load loans. Asynchronous function add contact, add book, add loan. Librarian add new records, stores new data for books, contacts, and loans. So those asynchronous here function are actually connected to our backend. So here's our backend. As you can see, we have that route post contacts, and then get, and then post for books, get for loans, and then post for loans. In our library.js, we have an asynchronous add book. As you can see, we have a run query, all query here to select it from the database. So this is SQLite specific syntax. It's not a JavaScript, it's an SQLite syntax. So the backend, think of that as the library storage and organization. So it where all books, visitors, and loan records are securely stored. So it's an underground storage vault. So table creation, It's like setting up the shelves and catalogs define where books, visitors, and loans record are kept. So that's the create table if not exist here in the server.js here. So this create table if not exist are um, it's like setting up the shelves and catalogs. It defines where book, visitors, and loans are kept. So yeah, books, contacts, adding and retrieving records. The librarian writes and reads logbook just as librarian writes records of borrowed books. The database stores and retrieves records. Express API, the library's front desk. So I think one of the best way to explain this, provide picture for all the library. Here's the library. I'll provide a picture for that. But the Express API, the library's front desk, so app.get contacts and app.get books, will provide so here, the app.get, here the contact. So it's like the library's front desk. Visitor asking for information. A visitor asks for a list of books, and the librarian API fetches the requested information. So there, here in the front desk is where the librarian fetches information. App.get loans, checking the list of borrowed books. A report who borrowed that, issuing a new loans, registered a new book loans. So here is the image. Here, well-structured library and tested code. Final metaphor, imagine the system as a grind library that will serve you for your life. The HTML is the physical structure of the library. JavaScript is the librarian who manage requests. And the database SQLite is the storage room where everything is archived. The Express API is the help desk that connects visitors with books. So here, let's add this to our metaphor. We're also going to discuss in this video a um, introduction of unit testing for web development. The Express API is the help desk that connects visitors with books. Yeah, so ORM. So let's start with the topic now, ORM. One table per inheritance hierarchy. So basically, the way we could relate this to our library metaphor is that in its library could have different organizational structures. In a library, books can be organized in multiple ways by author, by subject, or by genre. In database, data can also be structured in multiple ways, such as using different ORM strategies, one table per hierarchy, one table per subclass, etc. So the properties of an object or the associated class are stored together with the properties of all subclasses in a table. So here is the diagram for this here. Um, here you have person with the properties name, customer address, employee ID, persons. In these persons, it store all the properties of the base class and all its subclass. So name, address, ID, as this at the same time a type. So if you're wondering what that type is, that type is actually the name of those classes, the person, customer, and employee. So that's the one table per inheritance hierarchy. So it's one way of organizing the library. So the need for mapping a system. So if you're looking for a book in a library, you don't search through every shelf manually. Instead, you could use a catalog system that maps book titles to their physical locations. One table per subclass. In this variant, a separate table is used for each class in a class. Hierarchy. Since the class result indirectly from respective table, you don't need to store this information in an additional column as in the one table per inheritance hierarchy variant. So in this case, you don't need to store this name, person, customer, employee in a separate properties inside a separate table, like the type, like here, the type, because every um, table has its separate, every class has its separate tables. So that's the mapping. So basically, it's one way to map. Again, remember, it's one way to map the data to a relational data in object relational mapping. Another metaphor for this is that imagine you're translating language from one thing to another. So instead of converting or automating or manually converting the language, you just need to get a translator that will allow you to translate all the language automatically. So it's less prone to error and um, it allows us to translate our complex code because as our code gets complex, we have subclasses and those can be harder to convert to a relational data. So similarly in programming, when working with relational databases, you don't manually write SQL queries every time. ORM acts as a mapping layer between objects in your program and relational tables. Abstraction for ease of use. A library catalog allows users to search for books without needing to know exactly where they are stored. ORM allows developer to work with objects without needing to write raw SQL queries, abstracting database interactions. Handling complexity. If books were scattered randomly in library, finding a specific one would be difficult. A catalog system helps manage this complexity. Similarly, when dealing with complex object hierarchies like subclasses in programming, ORMs provide structured ways to map those relationships into relational database. So the core idea is that just like a library catalog helps bridge the gap between human-friendly book searches and the physical organization of books, ORMs bridge the gap between object-oriented programming and relational databases. So that's the core idea of this. One table per country class. This is very similar to the previous, but omits the table for the base class. Instead, the previous properties of the base class are stored in each table of the corresponding subclass. So from the word itself, this table or the properties of this base class are transferred to its subclass. ORMs are particularly useful for storing complex object structures in relational databases. For Node.js, the SQLized library is a good choice, which supports SQL database like PostgreSQL, MySQL, MariaDB, and SQLite, among others. SQLite or SQLite, non-relational database. So think of traditional relational database or traditional library. Uh, In there, books are meticulously categorized into sections, shelves, and rows. Just like data is organized into structured tables with predefined relationships. Each book has an ISBN, a primary key, and related information such as author details may be stored in separate tables connected through relationships. Now imagine a modern, chaotic yet highly efficient digital archive. Instead of sorting books into rigid categories, it stores everything dynamically based on demand. This is how non-relational database operate, optimized for speed, flexibility, and scalability. Uh, so that's the metaphor for this non-relational database. While the consistency of data is the most important feature of relational databases, scalability is the most important feature of non-relational databases. The functionality of non-relational databases, only one thing is common to all databases of this type. They do not use relations for managing data, but instead use other data structures. So types of not only SQL databases. So this is the structure. Key value databases. So think of key value databases like a library's card catalog, but with instant retrieval. You ask for a book by its unique key, ISBN, and it directly gives you the full details. Examples. Application of this is Redis or Memcache. Key value database, also called use associated arrays, is a data structure for storing data. So here, an example of that here. So we can use JSON, string, or integer. An associative array consists of a collection of key value pairs in which key serves as a unique identifier for retrieving a value assigned to it. Values can be primitive data types like numbers or strings, or be complex objects like JSON structures. So here, it serves as a unique identifier for retrieving uh, for retrieving a value assigned to it. Values can be primitive data types like number or strings or complex objects. So use cases for key value databases. Unlike relational databases, which define a data structure consisting of tables with rows and columns with predefined data types, value databases store data as a single flat collection with no structure or definition of relationships between them. So there's no structure or definition. It's a messy, but it's fast. You just need to have the ID. The reason it's fast is that it doesn't need to search all through all those connections or relationship. You just need to get the exact data. Due to its flat structure, key-value databases are quite efficient. Instead of searching for data across several tables, a single access via the key is sufficient. So that's the key-value. First, document-oriented databases. Example of that is my MERN app. So my MERN app use MongoDB. MongoDB use document-oriented databases. So document-oriented databases are a special form of key-value databases. Think of this as a library that stores books not by rigid categories, but as self-contained documents. Each book holds not just its title and author, but also notes, references, and metadata all inside one document. So instead of just book, it includes references, metadata, all relationship contained in one document instead of books. So instead of just one book, you get all the related resources, kind of like the reference in the at the end of the book. So it's included on that documents. The values in this database are always documents, which are not meant in the sense of Microsoft Word documents or similar, but document in a sense of structure compilation of data. So the structure compilation of those books and its reference makes it the book in one package that include all the things that you need to research about the book. The individual documents corresponding to records in a relational database are stored in collections, the equivalent of tables. So collection equivalents to tables, documents equivalent to row in a relational database. Formats for documents. Common formats for documents are JSON, XML, YAML, and binary JSON, with JSON format in particular being quite popular in this context. None of the other formats, not even XML, can be used as easily on all layers of web application. Two of the best-known example of document-oriented database are MongoDB. Graph database. So graph database, it's like it focuses on relationships. Here's the graph. Here's the collection actually for document the graph for that. So here, as you can see, it focuses on relationship. In this relationship, you can have this attributes located in. So it knows which books are often borrowed together, which authors are connected, or which books reference each other, making it perfect for recommendations and social networks, such as Facebook. Right, that's kind of like how Facebook databases works because it's more efficient for that use case. The nodes in graph database, data is stored as graph. A graph consists of different nodes which are connected by edges. In edges, you can have multiple attributes. The nodes represent the individual records, and the edges represent the relationship between these records, distinguishing between one-way relationships, directed edges, and two-way relationships. So two-way, it means that that node connect to that node, and then this node connect back to that node. So that's the unidirected edges. Kind of like the unidirectional communication in TCP or IP. Additionally, graph database use the concept of property graphs. In such a graph, the individual nodes and edges can be assigned additional properties in form of key value pairs. So key value pairs, remember it's like a property. So those edges can be assigned by a key value pairs as well, as shown in this figure. Used for graph database are good whenever you want to quickly determine or access specific data based on relationships between records. Column oriented. So think of this like instead of pulling entire books, you only retrieve the specific pages you need. If you only need author names, you just get that column of data instead of scanning whole records. So it's fast, just like key value pairs. So examples of this is APIC Cassandra and APIC HBase. So column-oriented database are databases where data is stored in columns. Unlike relational databases, the individual columns are not part of a table but instead are managed separately. In turn, the data of the individual columns are linked according to their order. The first entry in one column is linked to the first entry in another columns. The second entry is linked to the second entries, and so on. Use cases for this. So when only certain properties or columns of data records require access, for example, analyzing data. For instance, if a data set has 10 columns, but you only need the data from a single column, access is much faster with column-oriented database because not as much disk access is required. So instead of reading all data by row, as is the case with relational row-oriented database, column-oriented database allow direct access to relevant column. So um, yeah, that's it. So to sum it up, we were able to discuss relational databases and not relational or NoSQL databases. Basically, we were able to discuss tables and how the HTML, JavaScript, and Express were used to connect to that relational database. Additionally, we were able to know how to convert that um, objects to relational using ORM. So we knew how to communicate with database using ORM mapper for us to easily or to avoid human error. And then lastly, for NoSQL or not relational database, we discussed how the different types or data structure for easy access to our data, like key value pairs, column-oriented databases, document-oriented, and graph databases. So that has like available different available data types, unlike in relational database where you need to define your data types before you create the table. In this, it can store JSON, string, integer, etc. So let's go to the next topic, testing web applications. So uh, again, I'll start this with a metaphor. So here, well-structured and tested code. So the testing of this, you can think of this as okay. So let's do that in the next video, guys, because I have some errands to do. Errands to do. So thank you for watching and see you on the next video. Peace.